Hi, Assalamualaikum. Welcome back to Dynamics ECS 429. Today we're going to discuss on topic 1 kinematics of particles, and where I'm going to explain to you on one part which is on absolute dependent motion analysis of two particles. So in some types of problems, the motion of one particle will depend on the corresponding motion of another particle. This dependency commonly occurs if the particle is represented by blocks and interconnected by inextensible cords, which are wrapped around pulleys. So for example here, let's say we have a movement of block A going downwards, okay, along an inclined plane A, okay. And then it will cause a corresponding movement of block B up the inclined plane. So if this is our question and assumption, what happened is the total length will always be the same, but the length of SA will increase and SB will decrease. Note that what we're doing here is that we want to show that we can do this mathematically by the location of the blocks using the coordinates of and positions of SA and SB. But bear in mind, it must be measured at a point from the datum or a fixed point O. Okay, now if the total length is TL, okay, and the two positions can be related by this equation. Okay, so we will have SA plus LCD plus SB equals to total length. Okay, so what is LCD? LCD is the length of the cord passing over CD. So basically, TL and LCD are considered lengths that are constant over time. Okay, the length is constant over time, but SA and SB, the length or change over time. Okay, the length change over time. Okay, so so taking the time derivative expression, when TL and LCD is constant, when we derive it to get the velocity, it will become 0. So we will get at dSA over dt plus 0 plus dSB over dt equals to 0. Or we can write it VA equals plus VB equals to 0. So it means that VA, okay, it means and similarly, if we differentiate the velocity, we can get the acceleration relation, which is plus V equals to 0. So this can also be represented FB equals to negative VA, for example, or vice versa. Okay, so the question is, some students like to ask, can we assume VA to be positive and VB to be negative in the equation earlier assumption? Yes, you can assume it to be like that. But in the end, if you get your final answer to be negative, for example, the direction that you have assumed earlier means that your assumption is the other is wrong, and it will be the other assumption. Not what I'm saying is wrong. What I'm saying is, for example, the example, you do this question and then you get your answer VA to be negative 8 meters per second. What it means is your earlier assumption here, where you assume that block A is moving downwards, actually means block A is moving upwards. Okay, so what you can do is, or you can write VA equals to 8 meters per second is going upwards like that. Okay, all right, it's just as an assumption that you assume earlier, but if you get the answer to be negative, it means that the earlier assumption that you have assumed is wrong, and it will be the opposite direction. So nothing to worry about. Okay, so if you understand this question, I would like you to try to do this question here. Okay, now this question, determine the speed of block A, okay, if block B has an upward speed of 6 meters per second. Okay, so I have given you the answer here, which is VA equals to 18 meter per second, but I would like you to try and do the question. Okay, you can if you have any problems, you can always ask me back through WhatsApp. Okay, so try to do this question. Okay, all right.